once you have done this, I'm going to give you about 4 minutes to talk with your partner. What I want you to do, you and your partner, each of you write something about electricity. We learned about electricity last week, right? Try to recall what you were taught last week with electricity. 2 of those things, okay? In the next door, I want you to think about 2 things you know about magnets, okay? And down. No, just go off what you it's not. There's not really a right or wrong answer. I just want to know what you know right now.
Think back to last week's lesson. What did we learn about electricity?
You can talk with your partner though. You can talk with your partner. Use your partner.
Okay, think about the activities that we did. We talked about circuits, and there were different kinds, and we talked about think about something that we talked about. No, you have to say something specific about it. You couldn't just say something. You have to say something about it.
The wire and 1 paper clip in your nail. All you need is 1 paper clip. I don't know the color you're going to do. You want to do all right, guys. Just talk with your partner. I'm going to give you about 5 minutes to try to create. Who does not have a video? I'll be one to create your electromagnet. Remember what we talked about, and remember what you did last week to create that light bulb, to make that light bulb glow.
An extra person.
Nail, remember the nail is the magnet. The nail is going to pick up. Okay, I tell you what. Put your battery and all that back into the bag.
Oh, we did it! We did it!
Did you do it? Let me see.
No, you're tricky.
Okay, wait.
Now that look, that nail has to pick that paper clip up. Okay.
Pick it up like you just did. What? We did. That's not too cheap.
Oh, very good.
Did I get it?
It's trying.
It's trying. So y'all are like really close. That's like awesome. Okay, how do you think? Talk to me. How do you think it's doing? How do you think that nail's picking up that? Boom! From the battery. Okay. That's right. So we said what earlier? Electromagnets have what? Okay. So what's the electricity? The battery illustration in it on 488. Let's look at those diagrams. Okay, we have a south pole and a north pole. Okay, and there's some iron filings in the middle of those poles. Okay, what are they doing for the south and north? What are those poles doing? Yes, they're pulling towards each other. You know, when I looked at this, to me, it looked like really long fingers. And it looked like they were coming together. Because they are attracted to each other. Okay? And they're opposite. Okay? So opposite poles what? Look at your diagram. They attract. Okay? Give me an example of that. North and north. Those fingers aren't coming together in that picture, are they? They're really bending. They're going apart from each other. Okay? So, like poles, what? What do? They repel. Show me an example. What is an example of 2 poles repelling? Yes. North and north. What's another example of two poles repelling? South and south. Very good. You could draw either one of those in your guided notes. Okay, guys, look at your little bars down here at the bottom on 488. Okay, we have diagram of 480, 489. Where is this magnetic field the strongest? Where do you think this magnetic field is the strongest? Yes. On the end. Okay, that's a good observation. What about the distance? Where do you think in distance that these magnets are the strongest? Are they stronger when they're close together or when they're farther apart? Closer together, that's right. You can see this in your books, okay? The iron filings, they have attached to this magnet. You can see almost like a circle. Do you see that in your books? You'll see what I'm talking about?
Putting my hand on top of the bag.
Caleb.
And it burned you.
Remember, guys, we're doing 2 lessons in one day, so we have to move quickly.
Okay, guys. When you are a scientist, they like to perform experiments, okay? So, we are going to try to squeeze in a little bit of an experiment. I don't know if we'll be able to get the whole thing in today, but we're going to try. Okay? So the first thing scientists like to do is answer a testable question. Okay? Miss Sexton can come around and she can help y'all. You can sit back down and Miss Sexton will help. Okay. So the testable question is, what will happen to a magnetic field number of times the wire is wrapped around the nail? This is what you're changing. Okay, this is your independent variable.
Can I interrupt
You are
for just a
changing.
second? I know y'all are in a hurry, but I think this will help them. Remember the last experiment we did, I had the water in the back, and I had cups of water. And I told you that when a scientist does an experiment, they have to keep all the variables the same except for one. That's the only way that we will know if that one thing is making a difference. So when we did that, we had the exact same size cup, made of the exact same size material. We put water in that was the same temperature. We put the same amount of water in. We measured it. And we put the same amount of what we were trying to see if it was soluble. I had a teaspoon and I measured each one. The only thing that was different was...
Open, their listening ears are on. You have a new set of guided notes. Let me show you. Sorry. There they are. There's a new set of guided notes. You see that? 486. 486. 486. All right. So, you remember last week, you made your light bulb light up. Okay, and how did you do that? Do you remember, for those that were here last week? Yes. So you made an electric current, didn't you? I tell you what, I'm going, Miss Sexton, what were some things you noticed about what they knew about electricity when you were walking around?
They knew that opposite charges attract.
Okay.
They knew that it could hurt you.
Okay. All right. And some things that I noticed with your magnet, you know that magnets are attracted to metal, right? A lot of y'all know that. And they can be, magnets can be attracted to each other, okay? So, what I want to do next, we are going to watch a clip on an electromagnet. Watch it close because I'm going to be asking you questions throughout this, okay? That make up an electromagnet would be what? What would the two sources that you would yes?
Electricity.
And?
A magnet.
And a magnet. Very good. Okay, so here's what I want you to do. Open your folders. There's a piece of white paper in that folder. Pull that piece of paper out and then close your folder back up for me.